Yeah. Thank you, Chelsea.
Thanks for having me. We ready to learn about decision making? Yeah. Wow, there are a lot of you. Cool. My talk is called Decision Making for Maximizing Agreeability. My name is Chelsea Troy. I'm from Chicago in the United States. We're going to talk about pitfalls common to engineers when making decisions as individuals. Then we're going to talk about making decisions in groups. But I'd like to begin with an exemplary question. You see a statement on this slide here. Generally, it's better to optimize our code for legibility than for speed. Is this true? Everybody shut your eyes. How many folks agree with that statement? Let's see a show of hands. Show of hands, show of hands, show of hands. I see some hands. Okay, you can put your hands down, open your eyes. Generally, it's better to optimize our code for legibility than for speed. You see that word underlined there? Generally. What do we mean by generally? Generally means in most cases, and when we say things like this, we're often skipping a discussion of which cases we're talking about. We have a different word that we use to differentiate those cases. Context. Now, by context, what I mean is the descriptors that characterize our specific situation. The place where I grew up is a context. The city that I live in is a context. The industry that I work in is a context. The type of software that I work on is a context. The language that I learned as I was growing up is a context. And it's important for us to recognize those descriptors because they inform and characterize our perspective. Those things about me influence how I see everything. And to me, the way that I see things can be difficult to separate from the truth because it's what I see as the truth. Perspective is especially important in software engineering. And here's why. Computer science is not like biology or astronomy or geology or thermology or nuclear physics or fluid dynamics or any of the other sciences with properties that we spend time studying but did not create. Computer science is entirely human-made. We built computers, which means that at every step from its inception, our perspective played a role. There is no piece of computer science or software engineering that is devoid of context, because context informs the perspectives with which all of it was built. And here's how that can bite us. When we are unaware of the context that we're in, we can accidentally mistake our specific case, our perspective, with an imaginary general case that applies to everyone. An imaginary truth. Generally, it's better to optimize our code for legibility than for speed. Maybe, when we're writing end-user client applications, it's better to optimize for legibility than for speed. Maybe, when we're writing an open source application that relies on multiple developers across the globe, communicating with each other asynchronously, such that later developers need to be able to understand and maintain the code that the first developer wrote, then maybe it's better to optimize for legibility than for speed. Several years ago, I started implementing compilers and interpreters. For the first one, I was following the book Crafting Interpreters by Bob Nystrom. Has anyone here read that one? It's a good book if you're interested. I see a couple hands. Yeah. So I was going through the beginning of this book during the lexing portion where we start identifying tokens in the text of source code. And while I was doing that, I came across this giant case statement that switched on all of the tokens. I decided I could do a better job than that of expressing the hierarchy of tokens in my compiler. So I refactored all of that code into a series of conditionals. And I thought it read so cleanly, and I felt so smart. And I reached out to Bob, and I asked him, hey, out of curiosity, why is it done with a giant case statement when other solutions might be more legible? And he said he agreed that the tiered conditionals added legibility, but that the truth is that when you're writing a programming language, what's important is that the thing be fast. Because you don't have to worry about the speed of looping over 14 keys and values in your C# app or your Java app or your Python app precisely. Because the people who wrote the languages made them fast enough to give you the luxury of optimizing for legibility in the app. They optimized for speed so that we don't have to do it in end-user client application development. Let's talk about another example of the context hiding in generally. Generally, composition is preferable to inheritance. Shut your eyes. Shut your eyes. Hands up if you agree with this statement. Faster hands. Wow. All right, hands down, eyes open. Cool. So we've heard this saying before. We have an idea of what we mean by it. Once again, we have this word generally. Doesn't do much to help us differentiate the common case from its exceptions. I taught a class for several years called Mobile Software Development at the University of Chicago. We learned about Android and iOS in that class. Both of those frameworks rely heavily on having the client developer inherit from classes provided by the framework. It ends up making those classes really tough to subject to automated unit tests because Android and iOS handle their instantiation for you. And you have to use various hacks to instantiate them yourself for testing purposes. You have to go around the framework to do your testing. Why do it that way if it makes testing so hard? Well, it turns out that when you're trying to make complicated stuff happen on a device the size of my hand, it's really important to conserve memory. Which means it's really important to conserve the number of objects in memory at a given time. And it's a lot for a developer to think about, and likely an accessibility hurdle for a lot of client application developers. So, to take some of that load off those developers, the folks implementing the Android and iOS frameworks wrote that behavior into prefabricated classes with convenient hook methods for client developers to put their own code in. End-user application developers for mobile apps have the luxury of, end-user application developers have the luxury of preferring composition to inheritance because those framework designers used inheritance to solve problems that they no longer have to think about. That brings us to the question of what generally means. We agreed earlier that it means in most cases, but which cases? When someone's new to learning programming, we use the word generally to keep things simple. We don't want to expose them to all of the nuances and special use cases right away. It's impractical, it's complicated, it's intimidating. No one starts by writing a compiler or the Android framework anyway, right? But when we reach the point in our own technical advancement where we are responsible for teaching other people statements that start with generally, at that point, we're responsible for knowing what generally means. We're responsible to know which cases we're talking about when we say generally. You and I swim in a sea of context. And the thing about context is, it's very easy not to realize it's there, to take it as a default, as a given, as the general case. Let's say a programmer on your team makes a technical decision. Maybe it's in a ticket they're working on, or maybe they make a change without buy-in. Now we're in a retrospective or a pairing session or a pull request review, and someone asks them why they did it, and they say, it's a best practice. It's easy to see the motivation to say that, because tech culture thinks in absolutes. We say things like, you always want to dry up duplicate code. And it's more important for code to be legible than performant. We ask each other things like, what's better, functional or object-oriented programming? As if those things apply equally to all contexts. As if the decision-making in this field is just that easy. We teach programmers to think this way. So it's not surprising when a programmer sees a system running afoul of one of these universal tenets that they want to change it. As a result, programmers often use the term best practice to defend a choice without understanding what made that practice so purportedly best in the first place, and whether the set of circumstances that this practice managed to solve even matches the set of circumstances that they are in. How did that best practice become a best practice? Do we have a singular sufficient reason? Did someone influential write a book about it and make it so? Did some kind of study undergird the decision? Does a study's finding about recommendations in the aggregate accurately proxy an ironclad recommendation of what we should do in every single individual case? A best practice can be useful, even in most cases. And it is still important for us to understand what those cases are so that we can identify whether this case is one of them. Because when the system goes down at 3 a.m., consumers and stakeholders will not be impressed by the design patterns book said to do it this way. We're still responsible for the choices that we make. A rigorous engineer can justify a choice by saying, our use case has these needs and those vulnerabilities. This approach has these benefits and those risks. Our needs lined up with the benefits, and our vulnerabilities didn't line up with the risks, and so we chose this solution. That is, engineers need to know the contexts in which a best practice is in fact the right practice, or at least they need to be able to tell, we need to be able to tell whether our context is one of them. So that begets the question, how should we be figuring out what's important to us in a given context? And whether our solution, or programming language, or tool, or refactor, is the right one. To do that, we have to get into the habit of discussing trade-offs. The same way that you have to choose what's important to you when you go to a market and can't bring home everything, we have to choose what's important to us in a particular context when we're writing software. Frequently, giving up some of one quality can buy us more of another quality. So we have to understand which qualities matter to us in our context. If you can describe the trade-offs of the technical choices that you or your team are making, you'll be several steps ahead of the best practice conversation. So we figured out our first decision-making pitfall, assumed context. Let's move on to our second one, flattening our metrics. When engineers get the opportunity to make design and maybe especially tooling decisions, it's normal and easy and very common to fall into this evaluation trap that exhausts a lot of energy on the wrong things. It usually involves first making a list of all the characteristics that might matter about the outcome of this decision, and then treating every single one of these characteristics as equally important and worthy of maximizing. Because many of these characteristics have trade-off relationships with each other, it's kind of empirically impossible to identify a solution that outperforms all the alternatives on every single one of these metrics. So teams get to do a lot of hemming and hawing about the decision forever without arriving at a solution they're happy with. They also get fodder to denigrate whoever the last engineer is that made this decision, rather than understanding the role of context and trade-offs in how to make this decision well. Instead, I want to introduce you to a distinction between optimizing and satisficing metrics. Optimizing metrics are the ones for which more is always better. The ones for which, no matter how much we already have, more will always improve our product outcome. Code legibility might be a good example of this in the specific context of end-user applications developed by a team of developers, and particularly one that sometimes experiences churn, but I kind of think that's all of them. In a situation like this, the limit at which making the code more legible isn't useful doesn't seem to empirically happen all that often. So deliberately improving code's legibility almost always benefits our maintenance efforts. Satisficing metrics are the ones for which we have a clear idea of how good is good enough. These are our non-negotiable thresholds. More of this doesn't improve our product outcome. A great example might be performance. Maybe your app's animations only look smoother up to the frame rate that the human eye can visually process. So that ends up being a good ceiling, satisfying metric for animation quality. When you're making decisions, it can be helpful to narrow down the list of optimizing metrics to as few as possible. 0 if you can, but 1 or 2 realistically. Then, establish the threshold at which your options would satisfice on all the other metrics. Determine the deal breakers and the level of these things that you have to have in order for the deal not to be broken. Use that to narrow down the options to those that meet those satisfying metrics, and after that point, ignore those metrics and focus exclusively on the optimizing ones. Now, I think I see at least a few of you squinting in the audience back there. Do I have Eric Evans? Maybe not. But I figure people might be thinking, Chelsea, what the heck does any of this have to do with domain-driven design? So, first of all, modeling decisions in software can be deceptively complicated. Avdi Grimm gave this talk at Southeast Ruby in 2018. It's an absolute work of art. It's called Build Graceful Processes, and it's about building software to support and model interactions that take place over time. Most software tends to model the world as transactions, like point-of-sale purchases, a one-time instantaneous event in which all the necessary information must already be collected in order for the system to work. It's a poor reflection of the way things actually happen in the real world, which is over time, and with increasing amounts of information as we go on. And as a result, we have to maintain all this information and plan our workflows around this software that models the situation poorly. Decisions work very much like that. And thinking about the weaknesses and the ways we most commonly tend to model decision-making can help us design better software to support contexts where decisions have to be made. But I also believe that there's a second part to this story. DDD Europe generally includes a few different varieties of presentation. Examples of domain-driven architectures, of course, tutorials on how to do domain-driven design adjacent tasks like event storming, domain modeling, and so forth. We might think of these as the muscles of domain-driven design, the parts of the system that move our designs forward. My talks and workshops have always focused on other parts of the system, taking an analytical approach to technical debt, analyzing the risks in a software system, reverse engineering a code base, giving and receiving feedback, or now, decision-making. Why? I think an important part of the history of domain-driven design is that it is specifically meant to help us organize complicated software architectures. For plain old create, read, update, and destroy apps, it's probably overkill. Organizing a complicated software architecture isn't usually a thing people do alone. It's not usually a thing people do for the short term. It's supposed to last and serve a lot of people. People who are using domain-driven design have complicated, usually team-based, long-term systems to build and maintain. And that requires a lot of skills to execute effectively. I think of these skills working in teams, planning for the future, spelunking existing systems. These are the ligaments, tendons, and supporting tissue for domain-driven design. We need them to stabilize our system and keep it healthy, or even the strongest muscles will fail, given a long enough time period. We just talked about two giant decision-making traps that programmers fall into, like flies into a honey jar. First, we're really quick to move forward based on our own context without even realizing how specific it is, and act like we're solving for the general case without even collecting, let alone considering, perspectives that we'd miss on our own. Second, we're quick to make a list of decision criteria and then act like all of them are equally important when they're not. Both those traps wreak havoc in individual decision-making. So naturally, we've ported them to make the structures we use to make decisions in teams. And then we're shocked when people seem unhappy, even after we've used those structures to reach decisions. There's a bigger, thornier, spicier question here. Which perspectives matter the most in decision-making? Maybe it depends on the decision. Or maybe it depends on who's in the room. Or maybe it depends on who's not in the room, as we'll see a little later. But we'll revisit this question throughout our examples, so don't worry that you'll forget it. When we need to make a decision in a software context, we tend to reach for a couple of defaults. Perhaps the quickest way to arrive at a decision is to have one person make it. I suspect you've all trodden storied tech careers where you've made plenty of unilateral decisions, but we'll go through examples anyway as counterpoints to some of the options we'll discuss later on. Let's start with an office example. Suppose we're in an in-person meeting with our team and our office manager is deciding what to do for lunch. One way to make everyone happy would be to send out a menu, let everyone choose the thing they want. The problem is that requires a fair amount of coordination. Get the menu link, send it to everyone, collect all the orders, set a deadline, track down the person who hasn't made their order by the deadline, get the order, make the order, try not to make any mistakes, distribute the right food to the right people at the end, inform the person who wants to change their mind after the food's been delivered that they can't actually do that, etc. It's not always possible, given limited resources and bandwidth and time, to execute individualized decisions. The office manager might elect instead to just select some pizzas themselves and offer those to the group at lunch. No coordination, no asking anybody anything, one person involved, fairly quick process. Software regularly uses heuristics to select a course of action based on one single entity. For example, in the RAF distributed consensus algorithm, we distribute logs to a network of servers, and we'll run all the commands through a leader server that the server cluster has elected. How is that leader elected? A server, if it doesn't hear from another one before a certain timeout, puts itself up for candidacy, sends out a message to all the other servers that it knows about, requesting their vote for leadership. How does the server decide who to vote for? It just votes for the first server it receives that message from in a given term. This is not the part of the algorithm where any consensus building is actually happening. What about in tech at large? Where do we see the most prominent singular executive decisions? In those choices made by folks within their roles, of course, but most visibly at the extreme end in the industry's solo founders. In this lore lauded as singular heroes who had an idea, built an app, launched it, and reached these success and riches with, we're told, little or no help. During the 90s, when the consumer web was new, stories abound of founders like this, many of them famously, starting their tech empires by themselves from their parents' garages while they were home for university. When does this work? In situations where speed is of the essence, singular executive decision-making feels like the quickest and often the simplest route to a decision. But despite that advantage, it only works well under specific conditions. Before we talk about the conditions, I'd like to take a moment to remind ourselves of our guiding question. Which perspectives matter the most in this kind of decision-making? Which ones get to contribute? Basically just the decider, yes? Plus whomever has influenced that decider's thinking over time, but without a specific process for doing something to collect that, we're just relying on the singular decider's judgment and a little bit of chance. So when can that work well? First of all, it can work well when the stakes are low. Maybe this is a small decision that has a very small impact on other people, and we can entrust just one person to do it. Or maybe it's a personal decision. It really doesn't impact anyone else at all besides the decider. In these circumstances, it might make perfect sense for the decider to act alone. But I think we can agree that none of our three examples from before fit this criterion. Each of them impacts other people. The last one gave rise to many of the organizations that have shaped the culture of the industry that we work in, for good and for bad. So there must be another condition here. Creating situations that result in the decision made this way. What could it be? Here we go. When literally any decision beats no decision. This might be the case under a tight deadline, where the time remaining between now and lunch allows for no discussion, and it's going to be whatever lunch the office manager chooses, or else there's just not going to be any lunch. Or it might be the case, as we might argue it was for many of the garage founders, that nothing existed at the time to serve a need that they saw on a platform that could meet that need. Because the status quo was nothing, among other reasons, they faced low opportunity costs of failure. If they were wrong about their idea, or their execution lacked something, they were failing at their own expense. They weren't failing a bunch of people who counted on the existence of the thing yet. These two conditions mitigate some of the threats to coming to an agreeable decision that we face with singular executive decision-making. But now it's time to talk about those threats. What threats does the single decision maker face, or the people impacted by this kind of decision making? First, there's an impact to stakeholders to consider. And here, we're not just talking about venture capitalists or investors or some of the more targeted terms we sometimes mean when we use a term like stakeholders. I mean, anyone who might, by one means or another, find themselves caught in the center of the impact of this decision. Who are they? Well, we have to hope there either aren't any, which sometimes there aren't. Sometimes a decision is purely personal, but rarely so. Or that those folks chose this decider based on an accurate understanding of which perspectives are most important. And this person can accurately represent those most important perspectives and make decisions alone. If the person's decision is going into effect without review, then it assumes that only those perspectives that they represent matter. And maybe that's the case, but it often isn't. Returning to the pizza ordering example for a moment, it's possible that the office manager understands which folks in the office will be able to eat what. But if someone can't eat tomatoes, or cheese, or crust, let's say, or the toppings that the office manager selects, then they don't get lunch that day. In other words, this decision-making strategy trades expedience for some risk that important perspectives get excluded from the decision in ways that impact stakeholders in that decision. So let's try again. How might we better model those perspectives in decision-making? That's where this other default comes in, that groups often turn to in order to facilitate group decisions. A vote among a few different candidate options from which each voter can choose one, with the one that receives the most votes being selected as the winner. In our pizza example from earlier, this might look like the office manager selecting 3 options, maybe cheese pizza, black olive pizza, and green pepper pizza, and asking everyone who will eat lunch that day to select one of the options, knowing that whichever one receives the most votes is going to determine what gets ordered for lunch. Here, our analogy breaks down a bit because it would theoretically be possible to use those votes to determine how many of each pizza to order, and instead of taking a winner-take-all approach to the order, and that would result in a more agreeable outcome, usually, than winner-take-all. The thing is, in software decisions and team decisions, we often can't do this. Our resources, or constraints, permit us to select one option, one plan of action. For example, in the raft algorithm I talked about before, a candidate gets selected as the leader of the server cluster upon receiving votes from a majority of the nodes. In the event of a tie, the election reruns afresh. There cannot be 2 leaders for the system to work. One must be selected. Data-driven product decisions often employ some version of this too. Product managers focus on quantitative methods to find product market fit. They interview people who use the product or survey people in majority groups that they would like to see using the product. Or, if we're brutally honest, they triangulate info from product surveillance data, but that might just be the US. Today's product managers contrast their data-driven approach with the I built this for me approach that worked for founders in the 90s, the single executive decision procedure for product development that we talked about before. Despite its empirical strategic success back then, build for yourself now gets cast as immature and short-sighted. But our ability to create the products and features that these data collection methodologies describe derives from the bandwidth of the tech team to execute the ideas. So how does prioritization happen? Generally, according to the things that receive the most numerous response, or at least the biggest response from clients who have deep pockets. That's a weighted voting system, and we'll talk about that some later. When does a winner-take-all majority vote situation work particularly well? Again, before we list the conditions, let's reflect. Which perspectives matter the most in this kind of decision-making? This one sounds so idyllic in theory. Everybody equally, right? Sure, everybody gets a vote. Everybody gets an equal say. When can that work well? Well, it works particularly well when there are just two candidate options. It guarantees that provided you have a majority vote, an actual majority would prefer this option. Suppose you have multiple options and 3 people vote for cheese, 3 for olives, and 4 for green peppers. So green peppers wins the majority vote. If that dictates the entirety of the pizza selection, you might have an inoptimal solution. Let's say, for example, if everyone who voted for olive would gladly switch their vote to cheese rather than get stuck with a green pepper pizza. In that situation, cheese would have won. But we have not ended up with that result because we've gone with this majority vote solution in a situation where we had more than 2 candidates. It's also not only a condition for majority winner-take-all voting to work well, but kind of a condition for it to work at all, that all of the options be acceptable to the entirety of the voting populace. This is the big one that majority voting tends to miss completely. That's necessary for a vote to represent a preference, as opposed to, say, a need that precludes participation for some voters. If everyone's vote is to count equally, then everyone's stake in the final decision needs to look roughly the same. It can't be some people casting their one vote based on their preference for how to participate, and other people casting their one vote for their ability to participate at all. Otherwise, a tyranny of the majority, formed in part by folks with a slight preference for one thing over the other, determines whether members of the minority get to participate at all in the beneficial impacts of the final decision, or avoid irreparably harmful impacts as well. Suppose 6 votes for green pepper and 3 for cheese. Suppose also that all the people who picked green peppers chose it because they happened to like green peppers, but 3 of the people who voted for cheese did so because they're allergic to green peppers. If cheese had been chosen, everyone could eat. With green pepper as the winner, 3 of the group cannot. Is this a fair or acceptable outcome? Not really. So I think we can agree that neither of these models works well in all decision-making scenarios. What can we do? Are we forced to adopt a consensus procedure? In consensus, everyone has veto power. So everyone has to consent to an option before we can move forward. It can, used wisely, eliminate the opportunity for a tyranny of the majority to make a final decision that precludes even one person's participation. We nevertheless rarely see this option employed because it permits voters to halt a decision that overrides their preference. So within any set of differing perspectives, we'll see different preferences and we'll rely on voters not to veto based on those preferences as long as the unanimous decision is acceptable to them. As long as somebody's willing to vote no, even on acceptable decisions that don't match their preference, they can hold the decision in deadlock until everyone agrees to their favorite solution. If two people who disagree with each other are both willing to do this, the decision remains deadlocked indefinitely. Turns out, we have a few different levers we can pull on the way we use voting to alight on a decision path. For example, we could use approval voting. Rather than having everybody select just one option, let voters choose all the options that they find acceptable. And from those votes, the options with the most votes wins. That way, you're not causing people to choose between an acceptable and an unacceptable solution without being able to differentiate between the two. Take our pizza example from earlier. 6 people voted for green pepper based on preference, while 4 voted for cheese. The 3 people who can't eat the peppers would vote exclusively for cheese. Meanwhile, some of the green pepper voters would also select cheese, since they have only a slight preference for pepper. Out of the 7 voters who can eat green pepper, only 3 voters need to also select cheese as an option for cheese to top the approval charts along with green pepper. What this doesn't do is differentiate between someone's first and second preference. This could become relevant in the event of a tie. Ranked choice voting purports to model that situation. Voters in ranked choice voting place their selections in order from best to worst. This doesn't let voters leave a candidate off their ballot of votes the way that approval voting does, so it doesn't have a built-in mechanism for differentiation for a preference between acceptable candidates and unacceptable ones. In theory, ranking an unacceptable candidate at the bottom can help prevent that one from getting chosen, as long as enough people do that to offset the number of points that candidate receives from not being at the bottom for others. So it doesn't completely prevent a tyranny of the majority, but it mitigates the risk some. Or maybe we can get around this by introducing a mechanism to model those preference sizes. Give voters each 9 votes and have them allocate those votes among the available candidates, such that someone receiving 9 votes and putting 8 of them towards one candidate and 1 towards the second signals a strong preference for the first one, relative to someone who allocates all their votes for those same 2 candidates, with 5 for the first and 4 for the second. Is that enough? Is it enough to ask voters to choose a strong preference if they're worried about another unacceptable candidate being in the running? Each of these different voting schemata all attempt to do a similar thing with different drawbacks. They're all trying to accurately model the utility space of several different alternatives to a group of voters without requiring those voters to engage in discussion or collaborative conclusion about what to do. Usually the assumption here is that the group can't, or doesn't want to, or is too big to reach a decision by discussion, or that there is no discussion structure that's going to work for the group. Which perspectives matter the most in voting? The attempt here is toward egalitarianism, with no one's perspective mattering the most. Is that fair? Is that right? Before we settle on an answer to this, I'd like to talk about one last collective tech industry example. Folks know who this is? This is Steve Jobs in 2007, presenting the iPhone at Macworld. People love the iPhone as an example of visionary success for a tech company. And I love this example because everybody uses it while completely miscontextualizing it. Most famously, the iPhone's capacitive multi-touch screen made it possible to dream up any UI, unbounded by pesky keyboards. That feature enabled the iPhone's ascendance to the status of a platform for independent application development. It broke the market for existing phones. I want to talk for a minute about where that idea came from. Its roots came from Fingerworks. This was an accessible human-computer interaction company founded with the express purpose of creating input devices for folks with compromised fine motor function. One of the founders wanted to build a way for his disabled mom to continue doing all the things that she wanted to do. And that grew into the company, which Apple bought in 2005. It wasn't Apple's idea. Instead, it came from the singular executive decision-making of two people acting on behalf of the marginalized perspective of a person who could not participate in consumer technology the way it was designed at the time. And when they produced a way for that person to participate, it turned out that the result worked better for almost everyone else as well. They might not have anticipated something like that working. Indeed, Jobs had to be convinced to put that touchscreen into the iPhone. But once people had it, the superiority of the design was clear. In fact, by the way, most of the things you love about your smartphone started as accessibility features. They weren't features invented by majority vote, or even by the types of people who usually get to make decisions at places like Apple. And their perspectives were instrumental and necessary to doing anything new and visionary, anything more useful than what existed at the time. I think there's a case to be made that the perspectives that matter the most in decision-making are precisely those perspectives that typically get excluded from participation in the thing we're making decisions about. It takes a lot of courage to use this information, because it means when you're facilitating a decision that's going to have a wide impact crater, you have to go find precisely the interests that often aren't represented in this kind of decision, who don't even get a vote, or who always lose the vote, and focus on their concerns, the satisficing metrics, the deal breakers, before selecting a final option based on optimizing metrics. A process that does that would be likely to situate voting or executive decision-making within a larger context of candidate selection. To reach agreeable, to cover all our satisficing metrics, in other words, we need to first eliminate fear of exclusion by making all candidates acceptable. One exemplary way to do that might be to narrow down the candidates to those that are acceptable before moving to a vote or executive decision-making. Suppose a group of designers endeavors to select a color scheme for a consumer-facing healthcare services application. That decision might be made a few ways. Maybe a designer unilaterally decides on a scheme. Or maybe the designer comes up with some candidates and the team takes a vote. A common anti-pattern that we see in front ends is color schemes that prioritize branding over accessibility. Suppose that a company's colors are red and green. A site that relies on this color scheme is inaccessible to folks with red-green color blindness, which affects about 1 in 25 people. Accessibility examples, like food allergies, fine motor control loss, and color blindness, work well for illustrating the impacts of various decision-making protocols because they don't require a lot of domain knowledge to understand. But within given domains, similar limitations within constituencies dictate which parts of the set of candidate decisions lock some stakeholders out of the system. I suspect that within your domain, there are a few of these that you don't know about or don't know much about without going looking for them. How might we solve for situations like this? We might begin by expressly soliciting perspectives from those most affected by the decision, folks who use the healthcare app and their dependents, for example, and those most adversely affected by it, too, which might include particularly sick folks or even constituents who currently can't access healthcare at all. That's not a group that tends to get asked about decisions about a healthcare app, but it represents an often undetected false negative that silently prevents organizations from growing their impact or their user bases the way that they might like. Some folks who use the app might say they need a high contrast color scheme. Others might need one that accommodates various kinds of color blindness. Still others might get migraines unless they can see the app in dark mode, while another subset might rapidly get screen fatigue unless they can see the app in light mode. From this set of needs, we can come up with some options. It's worth noting that in this example, the options are not all acceptable to everyone. They can't be, because sometimes folks have mutually exclusive acceptance criteria. If some people get migraines without dark mode and others get eye fatigue without light mode, no one solution is going to work for both of these subgroups. It's tempting in these cases to go with majority rule, winner take all. But it's not possible to come up with a universally acceptable solution without prioritizing a color scheme with both modes. This is already extremely valuable information for designers to have at their disposal. In fact, rather than trying to select a winning candidate from a list that includes solutions that aren't acceptable for some voters, the team can take the time to ask which ones would be acceptable to a constituent population, and then, rather than select the one most approved, seek to understand why some candidates got marked unacceptable. There will be a lot of new information hiding in those answers. It may be possible to modify the candidates or replace them with alternatives that address the issues so that we reach this golden condition under which voting becomes most useful, the one where all candidates become acceptable to a population of voters selected to include folks who would have the necessary perspective to flag the unacceptable candidates. And that's not necessarily healthcare experts or software people. It's by design, folks for whom the system already tends to work really poorly. So perhaps in this case, our final candidate set might be to prioritize candidate 1, a light mode with blue and orange, and a dark mode that just inverts all the colors on the page. Candidate 2, a light mode with blue and a dark mode with orange. Candidate 3, a light mode and a dark mode that each use the same blue and orange and just flip the background and text colors. So we've got 3 candidates, all of which should prove acceptable to our voting population. Once we've got those acceptable candidates, we can vote to our heart's content. We can use approval voting to identify preferred alternatives. We can use ranked choice voting of some stripe to model the preference space. Finally, the top candidates, according to the voting procedure, might be selected outright, or they might go to a person or a few people for a final, popularly informed, judgment-based decision about which course of action to pursue. Though a process like this feels more onerous than a simple vote, it offers a set of steps to expediently deal with many of the challenges we face in unstructured discussions about what to do. It starts by uncovering and addressing irreconcilable differences in participation needs. It moves on to expressly focusing the candidate set, working with participants to change or replace unacceptable solutions until the group is ready to vote on options that would all be at least okay. At this point, voting can efficiently proxy a preference terrain, which can inform a final decision from a designer or a design team. Whose perspectives were centered in this process? First, the most impacted and the most marginalized ones. Then, zooming out from there, the entire body of folks voting on candidates. Finally, the last word has gone to the design team, theoretically the ones implementing the color scheme. Each stage has systematically addressed the pitfalls of leaving one of these groups out of appropriate focus, with clarity for everyone at each stage, in contrast to an unstructured discussion, about what will come out of their sharing their perspectives and what to expect next. The system asks for flexibility from people. It asks people to admit when solutions besides their preferred one would be acceptable. It specifically orients around acceptability, drawing a distinction that, left unmade, can lead to both roaring arguments about minutia and undiscovered exclusion or harm. When we build complex systems, it's easy to lose ourselves inside either of these. We can often use a more sophisticated model than majority vote or executive decision-making to achieve good results under challenging circumstances that don't match the conditions for those methods to work. But those systems are built on two important understandings that need to undergird our decision-making processes, both as individuals and as teams. First, recognizing that any perspective we bring to the problem comes with a specific, sometimes hidden context that we need to dig out and compare against other perspectives and contexts. And second, recognizing that most of the time, not all concerns are equal. Baseline acceptable and preferential are not the same. This is good enough and nothing is good enough are not the same. And any kind of group decision-making can only model the group's collective perspective when our selection criteria have already acknowledged and addressed those distinctions. I hope this has been useful to you, or at least has gotten you thinking about the ways that we make and model decisions on our teams. A final word before I yield my time to question, or not to questions, to lunch. I make online self-paced workshops that discuss some of the skills that I mentioned I think folks need. This is the discount code for folks at DDD Europe. It'll work for 1 week, so that's available to all of you as many times as you would like. Thanks, folks.